Meet Mandy. She is a word gamer and a Wordle fanatic. She is very competitive but not interested in competing with me because I see Wordle as a coding challenge and she considers using computers despicable cheating. Instead, she plays and competes with Martin. Martin is a professional editor by day and a formidable Wordle player at night. Each day, Mandy and Martin play a game of Wordle, then talk shit about each other's methods. Each player played the same sequence of 100 games. Then they argued ceaselessly over whose method performed better. Unable to agree, they sent me their anonymized scores for arbitration. This translates to the task of ordering or ranking sets of ordered categorical variables. And to compare such two sets, all you need to do is to assign a score to each category outcome, then aggregate the scores in each set and compare the aggregated scores across the sets. The case at hand is the simplest possible version of that, since the result is just the same as the number of guesses in each game. Then for an aggregated score, you simply just sum up the number of guesses each player made. Or in the case of sets of disparate sizes, you would calculate the average. Or in case of oddly distributed outcomes, you would use some more robust group measure like the median. Easy peasy. So here's the result. The median, the total number of guesses, the average, which is superfluous here because they both played exactly 100 games, but by a freak coincidence, they came out exactly equal. The two are perfectly matched. Their score distribution, they're very similar and both unimodal, both sort of normal looking, symmetric around a central value. In fact, there is no evidence in the data that the scores were drawn from separate distributions. The Mandy and Martin's method seem equally good at solving Wordle puzzles. I hurriedly relayed the happy news to these vocabulary athletes, and they did not react the way I anticipated. Listening to their foul-mouthed complaints made me realize that I had committed the principal sin of a data scientist. I had lost focus on the problem brief. While I diplomatically focused on data and numbers, my role here was to help stakeholders reach a decision. This case was never about statistical truths about distributions. Even though that's a valid point and perhaps necessary step, if we were deciding on whether to bet on Mandy or bet on Martin for the next 100 games, who would win the next 100 games, the fact that they are equally likely to win is a useful fact. But we are not doing that, and it isn't. This was about a game. The point was always about declaring a winner and supporting a decision. The two score sequences are in fact different, so the performances can be distinguished. Top-level statistics fail to deliver, so the task here is to come up with a metric that helps you distinguish between the options. There were no rules on how to do that agreed on in advance. So the first step on the task is getting stakeholders to agree to a sensible and fair metric that can distinguish the options. Now, so look into that. Neither player guessed right in the first try. Both players required 6 guesses twice. Neither player required more than 6 guesses ever. Player A had more guesses, had more games end in the second try. Player B was more successful in the third attempt than player A. Player A required 4 guesses more often than player B, and then player B again in the 5th guess. Comparing these differences made me think, so I asked my players whether they agreed to this statement. Is making an error an early guess less of a mistake than making an error at a later guess? And the stakeholders agreed. You get stakeholder alignment. The more guesses you have already made, the more information you already have. So my stakeholders agreed that the penalty cost of a wrong guess should increase the later the guess is made. With that agreement, I implemented a simple linear increase in the penalty such that the weighted score scales and the guess count, so that the weighted score scales as the guess count squared. Recomputing the scores and aggregating again, I declared player A winner by the tiniest margin, which made one of them very happy. I tell this short story as a reminder to myself to evolve from correctness to usefulness. To shift focus from the method to the impact. Of course, correctness and method remain important, but they're not enough. I'm not alone on this path. In fact, it's trendy in the field of data science to shift from data science to decision science, as this book from MIT Press emphasizes. I'll have more on that later, but I'm out of time. Thank you very much for listening.